Okay, folks, this is Lab 5 in week 5, and today I'm going to do two more problems involving hybrid analysis. We started this business of hybrid calculations yesterday, and the problem that I did for you was this one. In other words, you look at that geometry on the left side, and you should realize that this problem is more appropriately handled by uh, hybrid analysis. In other words, there should be solid elements there should be shell elements there, and beam elements. Okay? Now, I did this thing in class yesterday, but the entire thing was done as a single part. But I want to repeat that where it's made of an assembly. The assembly being the part that is the solid piece, the cylindrical piece, the part that is that surface, which is mesh with shell element, and the part or parts that are uh, made of these two lines, which are going to be meshed with beam elements. Now, you're asked to also use as many planes of symmetry as applicable here. Notice that the bottom of this thing is clamped, and these top ends are clamped too. So, and the surface is subjected to a load of pressure of 100 psi. Now, that being the case, you realize that assuming that this, uh, the edge of that uh, plate is completely welded to that cylindrical object, and these ends, the ends of these rods, or think about it as actually for now beams, okay, are completely welded to these corner points. There is a plane of symmetry, and that is cutting it like that. So you need to do only half of this. Now, the choice is yours, whether you want to make the object as it is and then use the saw to split into parts and things like that, different pieces, or when you make it, you just use half of the stuff, okay? And that's the route that I'm going to take today because I don't know how you're going to do that, but at least today, this is the way I'm going to do that. Okay, so let's go ahead and work it out. Yeah, the dimensions were given here in the class yesterday, and yeah, and then I'm going to come and do this problem. Okay. All right. Let's go ahead here. We start with the product file because we're solving this thing as assembly. If this problem was given to you on a test, it's entirely up to you, unless you were specifically asked to use a single part or specifically asked to use assembly. The choice is yours. So this is an assembly. I'm going to save it. So file, save management, save as, uh, one level up, desktop, new folder. I'll call it a hybrid as assembly. Okay. Okay. Let me insert that cylindrical object first. So insert a new part in there, and I'm going to call this thing right click properties, cylinder, and cylinder. Okay, let's make it. Double click on that horizontal plane. I will sketch half a circle, uh, something like this. And I'm going to close it from this point to that point. And I think the radius of that was uh, zero 0.5. Yeah, the rate is 0.5. So let me give a dimension here. 0.5. All right. Exit and pad it. Well, I'm not in the. Notice that I'm not in the part design. So if you want to pad, you have to go mechanical design, part design, and then you pad it by 2 inches. That's what the height is, 2 inches. So this is half of that cylinder. Okay, and exactly the way that I did this thing yesterday, I'm going to create a surface by going up, creating a plane 1 inch above that XY plane, and then draw the stuff on it. But this is going to be a separate part. Uh, by the way, everything is going to be made out of the same material, therefore I can make it an assembly and then at the end apply steel to that product. Okay? Or if you have different material, then you have to do it one by one as you go along. All right, so we go all the way to the top, insert, new part, say no, and I'm going to call this thing plate. Right click properties, plate and plate. I want to make sure you know that if you solve this thing with solid elements, all solid elements on a test, you're going to lose substantial number of points. Because you may look at this or say, you do it like that. Yes, that's true, but you're being told that train your eyes so that if you see beams like structure, model it with beam. If you see plate like structure, model it with shells. And solids, solids, okay? Yeah. So let's make it. Double click on that. We create a plane 1 inch above. So here's a plane 1 inch above. Good. And in that plane, I'm going to sketch basically half of that, uh, uh, half of that plate. Okay. So here it's actually very useful because what I can do is uh, I can project that half a circle. Okay, and then complete the rest. Because the way I did it in class, because it was a full circle, I couldn't do it something like that. That's why I did it initially and then went and deleted it. But here, it's half a circle, that's okay, for a reason that I'll mention in just 1 minute. So it looks like that, and like so, and you close it up, and there. And we're going to dimension it. Okay, so this one is okay. Uh, this one is 2, and this one is 1, right? 1. And exit, and fill it. Fill. Now, put a surface here by filling this two-dimensional sketch. Now, as soon as you say surface, you can't do it in part design. So you have to go to, for example, you can go to wireframe and surface design, look for the icon which says FILL, right there, FILL. This is already selected, and you say, okay. Now, I could not do that yesterday because you can FILL uh, easily by having a closed curve. There's another closed curve in it, which would have been that circle that would cause a problem. Of course, in the new releases of CATIA, you can still handle it. It's just that there's more work. That's pretty much it. Okay, good, good, good. So apply. We don't want to apply material. Everything's going to be made out of the same thing. Now we're going to go and say insert a new part, again in there, and I'm going to call it the how about that, vertical beam. How about that? Right click properties. I'll call it vertical. How about vertical support? I'll call it vertical support because it could be beam, it could be cable, and these are behaving differently. Initially, I will do beam, and then I'll show you, as I did yesterday, how to fix it or how to change it so that it is a cable. If you're told that that's a cable, you have to do those changes later on. Okay, let's go make it. Well, I want to draw a line going up there, right? So one way is create a line, point and direction. I'm going to hide the sketch. Oops, Control Z. Okay, hide the sketch. Control Z. Let me see, can I not hide the sketch from here? Not here. Sketch, hide. Oh, that's because the plate was hiding, so let me bring it back. But I want to hide the sketch only. Well, it looks like they go together. Let me see what else is the. Okay, no problem. Cancel that. Let's see what we want. What we can do is we can create a point right at that location. That's kind of strange because I'm not sure why these are hiding. Okay, so let's do the following. Create a point. For example, on, let's see now. Okay, on a curve, on a surface, no problem. And this surface, and the point that we want is maybe I'll do it differently. On a curve, on this curve, this is the curve, and it's 0 length, so fine. Is there a point created there? Where is this point? Okay, so all right. What I want to do is hide the sketch here. Okay, so to do that, let me see if I go to plate. If I go to plate, I can hide the sketch. Still there. Okay, and now I go back to the uh, vertical support part. Okay, I say create a point, and the point is I'm sorry, not a point. Create a line. Cancel that. Create a line. Create a line. Okay, and point and direction. Point and direction. The point is that corner point, and the direction is Z, and the height is 3, length of 3. Okay, and then we say good, done. Excellent. So we go all the way to the top, all the way to the top, save everything. Well, let's apply material to it. Apply material, uh, steel on that part. Say okay. Now we save everything. This is the file save management. File, save management. There's the product, save as. Uh, yeah, it's right there, right? It's in hybrid as an assembly. Good, good. Yeah, that's fine. Okay, all right. So what we're gonna do is now go to analysis and simulation, generative structure analysis. It's a static problem. CATIA sees a solid parts, immediately measures it, which is fine, no problem. And now we have to mesh this shell, the surface with shell element. You click on the mesh support, shell, arc-tree triangle mesher. You select that, and I'll put down a small number here because that's a gigantic one right there. This is, yeah, something like this. You can see the sun and the shell is over there. All right, fine. And then we're going to apply the thickness. The thickness with 2D property on that is 0.1. That's what I was told yesterday. We were told yesterday. Very good. And now we have to mesh this beam. Okay, you click on the beam mesher and you select this and it'll take it. If this was a sketch, you would have to go join it. But because it's a wireframe, it's a wireframe basically. It's a line in space. You don't have to join it. This whole thing was 3 inches long, so they put 3 elements there. Okay, if you want more, you can just put more. Actually, let me put point. I don't know, 0.25. That's fine. Okay, good, good. And the cross section, click on it. 1D property. Select the support, and it's a rectangle. Click on the wrench. 0.05 by 0.05. That's good. And for orientation point, I select this coordinate point. And if you do that and you zoom in, you see that actually it is in the proper orientation. And if you don't believe me, just make this thing bigger size so that you can see that it's all lined up the way it's supposed to be. All right, good. Now, the bottom of this is clamped. The bottom of that is clamped. And right now the problem says the top of this is also clamped. Good. And this is subjected to a pressure of 100 psi. So here's a pressure on that face. Let's see now. 100 psi, except that this is pushing it down. Yeah, that's good. That's good. If you put a positive, it pushes this thing up, which is not what we want. Now, yesterday I showed you that everything looks fine, except that when you run it, it's going to bomb out. First of all, one thing I forgot to do, and I haven't, this is very critical, please. It's very critical, and those are symmetry restraint. This slider surface on it. So surface slider there. Now these lie as shell element lie in the XZ plane. So user defined restraint, this edge and that edge lie in the XZ plane. As soon as you say XZ plane, no Y translation, rotations opposite. These are critical marks that people may be using if they don't do it. It's easy to forget also. Okay, so let's save everything and run it and watch that it fails. Actually, you have to do the analysis, right? File, save management, analysis, save as in that folder, hybrid as an assembly, fine. Say okay, and run it and watch it fail. And the reason that it will fail is that these parts don't see each other, right? So watch it there, and if you do animation, you can see that they have no idea that they're holding each other basically. So we say, okay, deactivate this, deactivate that. All right, So we assume that this edge, the edge of this shell surface, is completely welded to that. So we need to create a connection between the surface of the cylinder, second component, let me hide that edge, okay? That face and this edge, there's a connection between them, and the connection is fastened. So let's do it right now. So here is the fastened in the face, fastened is in the face. You select that and you say okay. Notice that it does put a fastener sign there. All right. Now, when we run it, you see that still fails. You'll see why again. So let me run it and watch it fail one more time. Uh, okay. Let me change the scale here. It didn't fail, but tell you what happened here. Um, it didn't fail, but let's watch something here. Change the scale. You see, it didn't fail, but it doesn't know this is connected to that. Okay, so deactivate. So it is in a sense failed. So what we're going to do is create a connection, another connection between the, oops, between, let me find that, between this end and, let me bring this thing into the show mode, okay, and that end of the surface. Now if I'm having a hard time picking it, let me hide that. If I'm still having a hard time picking it, because this is blocking me, you can either hide it from here and then select this point. Oops. Here, try it. Hide this. Oh, wait a minute. I wanted the corner of this. Let's bring it back. Okay, I don't know what I picked here, so let me remove this. Okay, let me hide that. Select this. One more time. I'm doing it one more time. Select this. The end of the line right there. And then bring that guy back. Hide the line. For the second component, select this corner. It's so easy to screw this up. Good, 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 good. Now, where's my line? The line isn't hiding. Okay, you might say, you know what? You created the connection here, yes, but can I make it fasten? If you try, let me try it. If you try to make it fasten, it's going to come back says, I can't do it. There. So when it comes to point and point, it cannot be fastened. You have to declare them as rigid. We did that yesterday. Let's try it again. Uh, uh, you have to do it rigid. See that? You rigid, you won't find it in the face-face connection. You'll find it in distance connection. Right there. The first one. The very first one. You click on it, you select it from there, and it says, I took it. Okay, now, I will come back to this transmitted degrees of freedom for now. Okay, just leave it the way it is. And let's run it. Everything is going to work fine. You'll see. Okay, fine. Let's activate the deformation. That's the way it should be. Let me animate. You see, this is being pressurized, goes down. It carries that with it. The only thing is that this thing is bending because these are welded together and it's beam. If it's a cable, then this doesn't happen. So how do I make it a cable? So we say, okay, close it. Go to the properties, double click on that rigid look rigid connection. Remember I said I'm going to come back here? Transmitted degrees of freedom says rotations are not transmitted. Okay. Now, the other thing is that if that's fine, that's going to look like cable. It's going to go down. Let me actually run it and show you that it goes down, convince you that it goes down. It does. Activate, animate. So it doesn't bend. See, this guy doesn't bend. It just goes straight down. The only problem is that because that top one is a clamp, rotations are fixed there, a cable doesn't understand rotation. So we say, fine, let's do this. Let me deactivate that. This cannot be a clamp. It must be, you delete it. You go and define user-defined restraint. You select that point. You say, hey, you cannot go in any of the three directions. That's what a pin is, or yeah, a pin is. You'll see that when I run it, it comes back with an error message, and it won't run, and I'll tell you how to fix it. This is exactly what we did yesterday. So this is the second time you're seeing this thing. If you're a first comer, you might wonder why it's happening. I've already done that, and now notice that I released degrees of freedom here, I released degrees of freedom there. I didn't release it, but didn't say anything about degrees of freedom rotation there. So this cable is free to spin about that line. That being the case, I go to that last restraint that I put in there and say, hey, you cannot rotate about the Z-axis. That means it will not be able to spin. Now let's run it. Done. No problem. And if you look at the deformation, okay, and animate it, you see, it takes this thing down with it, and it acts like a cable. It just goes down. There is no bending thing in that diagram. All right. Now, let's look at the deflection. Maybe it's easier to see it with deflection. So average ISO, and look at the rendering material shading, and you can animate it, and it's like that. Now, if you want to see it exaggerated, let's change the scale here. Maybe we can see the displacement of the cable better. Maybe I make it the 50. Yeah, you can see that. You can see that this is acting like a cable. It's just stretching. That's it. Okay. And that takes care of this part. Now I want to go and do the second problem. And my second problem is like so. You look at that, immediately you have to realize that this needs to be done as beams, this one as plates, and this one as a block that's sitting on it, basically, solid block. And these are clamped, these ends are clamped, and this is sagging under its own weight. Okay, so let me go ahead and do this. The dimensions, let me see now, 6. I'm gonna write this thing down, 6. The height of this guy is 4. And remember, there is a plane of symmetry here, so you do only half of this, okay? The thickness of this plate is 0.25, and the cross section of the beam is circle with radius, diameter 0.25. Okay, so here's what we're gonna do. I'm gonna create this this surface, okay, and a point underneath it for that. All right. We may have to come back and forth between this. So first thing I'm going to do, I'm going to make a plate which is 14 by 2. 14 by 2. Okay, so let's go here. start with the product. I have a choice of making this thing as an assembly or a part. So I'll do that as a part now, okay? Uh, it's entirely up to you. So we do it as a part. I do it as a part. All right. So on that plane, I will sketch. All right. Let me see now. The rectangle. 2 by 14, right? This is 2. This one is 14. 14. Okay. Exit. And I will put a surface on this, FILL, right there. FILL. We say okay. Good. All right. Then I'm going to put on that a rectangle, which I'm going to pad it up. So on that same plane, I will sketch. It doesn't matter which side. I'll make it a rectangle, 2 by 4. Okay, so let's give these dimensions. This one is 4. 4. And this is 2. So, okay. Exit. I'm making already half of the model. That's what I'm doing here. And then padded, obviously we can't do padding here, so I have to go to part design and pad it up by, is that 4? Yeah, 4 inches. Up by 4. There, so this is my block, okay? Now, I'm going to create a point down here because I want to create a line between that point, that end point, and that point down there. So while we're at it, I'm going to create a point with coordinate minus z being minus 6, minus 6 down here, and then create a line between this point and that point. Very good. Go all the way to the top. Make everything out of steel. Apply material, steel on this part, say okay. And we're done here. So we're going to go to generative structural analysis. CATIA immediately measures the block. You can see that it's a solid object, immediately measures it. We have to do the rest. Let me hide some of these sketches. This sketch I don't want it, I'm going to hide it. And there was another sketch there probably. I'll just leave it like this. Now we're going to mesh this thing with shells. So right there, there, we say okay. Too big. So let me make this thing at 0.4. That's more respectable. And you can see the mesh if you want. Right-click mesh visualization. There. Okay. Deactivate. And I'm going to give it a thickness to the shells. I'm going to give it a thickness of, I can't see what it was, thickness of 0.25. You can see that, 0.25. So 0.25. Very good. All right. And then I'm going to beam elements. You click on that. You select this because this is not a sketch. It's a wireframe. I can mesh it. And that height is that element length is fine. And now if you look at it, you can see if you activate the mesh, you can see even the beam elements. You have the solid, the shell, the beam. Let me deactivate that. And we're going to specify the 1D property associated with this beam. The circular or cylindrical, the radius is going to be specified, and the radius is 0.125. 0.125. The diameter was 0.5 in the drawing, and then we say okay. Good, good. So let's apply the restraints here. Uh, Remember, we did half of it, so that is on the surface slider. User-defined restraint. This edge is in the XZ plane of symmetry, which means no Y, rotations, opposites. Okay, very good. Now, that bottom point is clamped, so I'm going to hide that point. Don't put a clamp on the point. You clamp that, and there. Okay, and you're going to give a load. The load is gravity right there. See that? Acceleration. You click on it. You select everything. If everything goes, so this is a single part, it doesn't matter, so everything is going to be affected. And the icon for it is, must be somewhere here. Right here. You see that? You see this? Okay. And this and that. Oops. Okay. So all of them in the direction Z 386. Okay, I give it acceleration 385 inch per second squared. Or if you want, you can put 9.81. It's going to convert it to inch per second squared, and it's going to give this number to you. Okay. Now when I run, it's gonna fail. You'll see why. Okay, so let's run it and see that it actually fails, and we discuss why it fails. Because these things are going to move. They don't talk to each other. These elements don't talk to each other. You can see that right there. So look what happened here. For example, yeah, look, these are not attached to each other. This is not attached to that. So I have to make some assumptions here. I'm going to assume that everything is perfectly glued together. Deactivate. Where is this guy? This mesh deformation. Deactivate it. So I will create a connection between that surface for the second component. Let me hide that. Select the bottom of this, and this is going to be fastened. Okay, perfectly glued. Now, while I'm doing this thing, these are generated. I can do it at the end, or I can do it right now. Fasten. This is fasten. Here's the fasten on that, and then say OK. And I have to say the end of the cable is fastened to the corner of that shell, but fasten does not work there. It has to be rigid because it's point to point, right? So let me go ahead and bring this thing to the show mode. So I do another connection. I'm going to hide that. Select this endpoint. Okay. And for the second component, get that surface. Hide that guy. Hide this fellow because I won't be able to pick it. That fellow. If these are perfectly welded together, this connection must be rigid. Rigid, you're not going to find it in face. You have to look in distance connection for it. And that guy. And this is not a cable, so you don't have to release any degrees of freedom. And let's run it now. Hopefully everything is going to be fine. I'm pretty sure it is. Yep. Look at the deformation. This is going to sag under its own weight, you see. So go down here, activate, and change the scale so that you can see things. There's the scale, default, and then say OK. And let's animate. Yep, you can see that. It makes this beam also bend, and that takes care of this problem. This is coming from an old midterm. Good luck and have a good weekend.